Hi, today we're looking at lesson 3-2, solving inequalities by adding and subtracting. Remember, take something out to take notes on. If you got any questions as you're going through this, write down the notes. You can pause the video at any time to take notes, and when you're done, after each example, you have to check it out questions that you're going to want to complete on the worksheet. Today we have two learning targets. The first learning target, I can solve one-step inequalities by using addition. And the second one, I can solve one-step inequalities using subtraction. So we're just looking at the addition and subtraction operations today. The properties of an inequality. With addition, we can add the same number to both sides of the inequality and the statement will be true. So if we were given the inequality 3 is less than 8, we can add 2 to both sides. 5 is still less than 10. Algebraically, that would look like this. Have the inequality A is less than B, add C to both sides, and that inequality still holds true. Looking for subtraction, we can subtract the same number from both sides of an inequality, and the statement will be true. So for our numbers, 9 is less than 12. That is definitely true. We can subtract 5 from both sides, and 4 is still less than 7. Algebraically, that will look like A is less than B is our inequality we start with. And when we subtract C from both sides, that still remains true. Keep in mind these properties hold true for the other inequality signs. Greater than, equal to, and less than or equal to. Now it's time to look at an example. So our first example, we have x plus 12 is less than 20. To solve this, we want to get the variable by itself and then graph the solution. So to get the x variable by itself, we want to subtract 12 from both sides, leaving us with x is less than 8. To graph this, since it's an inequality, it's less than, not equal to, we have an open circle at 8, and we're going to shade it everything to the left. It has to be less than. Everything over here is less than 8. Remember from our last lesson, our shading's in the same direction their inequality goes when our variable's on the left-hand side. Our next one, we have d minus 5 is greater than negative 7. So for this one, we had to add 5 to both sides, and we end up with d being greater than negative 2. Again, since it's not equal to, it's going to be an open circle at negative 2 and shading everything to the right. So again, we have our open circle here at negative 2, and we shaded everything to the right of negative 2. It has to be greater than negative 2. Our last problem, we have 0.9 is greater than or equal to n minus 0.3. So for the last one, we add 0.3 to both sides of the inequality, resulting with 1.2 is greater than n. And again, keep in mind we always want the variable on the left-hand side, so we reverse it. So n is going to be less than 1.2n, less than or equal to 1.2n. To graph it, we have a closed circle at 1.2, and we shade everything to the left because n is less than that number. So keep in mind we want to end up having the variable on the left-hand side. We can't change our inequality, our sign just flips around. And now it's your turn. Do these 3 check it out problems on your sheet for following example 1. We'll go over those in class in the next class period. With inequalities, there are infinitely many solutions. So how can we check the solutions of an inequality when we come up with one to see if it's valid or not? One way we can do it is to check the endpoint. And the other one is to check the inequality symbol, what we have going on. So an example would be, we have x plus 9 is less than 15. Solution, we get x less than 6, because you subtract 9 from each side of the inequality. So now to check it, 6 is our endpoint. So we can plug 6 back into here, and 6 should be the solution if this were the equation. So putting 6 in for x and changing inequality to an equation, this is now equals. This is true. So our endpoint is a solution for the equation. Now to check, again, check the inequality symbol, make sure we're going the right direction. Let's pick a number less than 6. We could pick 0. Plug 0 into the equation, or the inequality. Substituting 0 into the inequality, we get 0 is less than 15. And yes, that is also true. So our solution, our solution to our inequality is correct. Let's look at this example. Sammy has a gift card. She's already used $14 of the total value, which was $30. Write and solve and graph an inequality to show how much more she can spend. So let's work through this problem through. So with any story problem, we need to first define our variable. We're going to let G equal the amount of money remaining on her gift card. So our inequality becomes the amount of money remaining plus what she'd spent has to be less than or equal to $30. We can't make it equal to 30 because you could still have money left on there, but it has to be less than or equal to because it can't be over 30. Solving the inequality for G, we subtract 14 from both sides. We want to solve for G. G is less than or equal to $16. She can spend up to $16 more on her gift card. So in shading this one, we do a closed circle at 16 because she can't go over $16. Since this is a real world problem here, it's going to be every number down to 0 because she can't go in the hole on her gift card. So at 0 is also a closed circle here. So she can spend anywhere between 0 and $16 on her gift card. Now it's your turn to check it out. Again, keep in mind that this is a real world situation here, so watch what your lower limit's going to be on inequality. Example 3. Mrs. Lawrence wants to buy an antique bracelet at an auction. She is willing to bid no more than $550. So far, the highest bid is $475. You want to write and solve an inequality, determine the amount Mrs. Lawrence can add to the bid, and then check our answer. So let's define our variable. Let X represent the amount of money Mrs. Lawrence can add to the bid. So our inequality becomes she has $475 as her highest bid. So far it's been the highest bid. She's going to add X dollars more, but that has to be less than or equal to $550 because that's her upper limit. She wants to bid no more than $550. Solving this inequality, we subtract $475 from each side of the inequality, leaving us with X is less than or equal to $75. So now let's check and see if our solution is reasonable. We can take our endpoint, $475, and plug that in to our equation. So checking our solution, we have our $475 plus what our solution was, we said $75. And yes, that does equal $550. So our endpoint works. Now let's pick a number less than 75. So for this problem, we just picked the number 50, and we plug that into our inequality. $475 plus 50 is 5 1/4, and that is less than 550. So our solution of X is less than or equal to $75 will work. And now it's your turn to do the checked out for 3. So we just completed the lesson for 3-2, solving inequalities by adding or subtracting. So at the end of this lesson now, I should be able to solve one-step equations using inverse operations, adding or subtracting. It's the same thing we did with equations, solving equations. Try to keep your variable positive, meaning you may have to add or subtract your variable, or add your variable to the other side of the inequality to keep it positive. And then you should be able to keep in mind when writing the solutions, write the variable on the left-hand side. So your variable is greater than, less than, equal to another number. Keep it on the left-hand side. So good luck. If you have any questions, bring them to class and we will go over them. Remember, you should be taking notes through all this. Thanks. Bye-bye.